Hello, welcome back to Brush Up on Basics. Today's segment will be basic signs and symbols. When you're doing math, any category of mathematics, you have to know the different signs and symbols, what they mean, and how to use them. It is so important that before you try to take any form of tests or quiz, you familiarize yourself with the various signs and symbols that are in math, whether it is algebra, geometry, um, percentages, simple interest, whatever segment, whatever category of mathematics that you're trying to learn, or you're trying to do a quiz, or you're trying to take a test, or you're trying to maximize your knowledge of, you have to know the various signs. Now, on the board behind me, I have an array of signs. Some of them you might not know. You might know all of them. But basically, these are the basic mathematics signs and symbols. Now, these are not all the signs in their totality. There are so many more signs. I cannot even begin to name them for you because I would need three more boards just to just to be able to get all or to capture all the different signs and symbols that they have in maths. So I'm not going to try to show you all of them. What I'm concerned about is the basic signs and symbols of mathematics. What if you're leaving sixth grade to go to seventh grade, or if you're in 11th grade or 10th grade, or if you're in first year or second year of whatever, if you're in college, you must refresh yourselves on the different signs and symbols. You have to know them. So I'm going to start with maybe the most simplest ones, and then I graduate, I go further and deeper as I go. And then when I show them to you, and I give you, remember, I'm limited on space right here, so I'm going to give you an example of how to use it, the name of it, and how it's used, and then we'll go from there. Soon we'll be able to take all this off the board, and once we complete this segment, you would be able to tell exactly what each one of these signs represent and how you use them. The first one here, we all know this. This is so very, very, very simple. It's the equal sign. It is simple because it's a sign that we use so regular. It is the equal sign. X equals 4. It's the equal sign. Or you may have 2x plus 5 equals x minus 6, an algebraic equation or an answer, what a variable represents. The variable x equals 4. It's the equal sign. We are familiar with it. That is probably the most simplest of signs because we use it so often. So it's the equal sign. After the equal sign, I have the not equal sign. It's an equal sign with a slash through it, meaning it's not equal. It is not equal to. So if you see this, they might ask you true or false. They might say 2/3 is not equal to 0.66. Is that true or false? And you should check one true or the other false. But 2/3 is equal to 0.66 because 2/3 is 0.66. So this is not a true statement. 2/3 is not equal to 0.66 is not a true statement. 2/3 is equal to 0.66. That is a true statement. 2/3 is equal to 0.66. These are little things that you should also know. 2/3 is 0.66. 1/3 is 0.33. 1/4 is 0.25. 1/2 is 0.5. 3/4 is 0.75. These are things you should already know. You practice with them so you get familiar with them. So when you see them on a test sheet or on a quiz or in a math book, it is second nature. So we went through the equal sign and the not equal sign. Now here's another sign. Something similar to that. Excuse my drawing. I cannot draw so very well. But actually, it is the very similar. Very similar. High similarity. It's a high similarity, meaning that more than likely it's a high approximation. More than likely, the two triangles, for example, triangle ABC, similar to triangle EFG. So here you would have, for example, in geometry, they will give you this little symbol, which means triangle. We have it here somewhere, right here. Anytime you see this little symbol, it means triangle. So for example, triangle ABC is equal or similar to, this is not equal, I'm sorry, is similar, very similar to triangle EFG. More than likely, sides are the same and angles are the same. Very similar. And definitely shape the same. So this is very approximate, highly approximate, very similar. Now, we are finished with the equal, not equal, and the similarity, the very similar symbols. Here we have another symbol, and it's like an arrowhead pointing to the right. So this means greater than. If it's pointing to the right, it means greater than. So, for example, true or false, 6 is greater than 7. That would not be a true statement because 6 is not greater than 7. This sign means greater than. 6 actually is less than 7. So you have the one pointing to the right is greater than, and the one pointing to the left is less than. So this is less than. It's pointing to the left. So if I read it correctly, I will be able to understand the question. 6 is less than 7. That is true. That is absolutely correct. And, for example, let me put that 6 back. 6 is not equal to 7. That is also true. Absolutely right. So we have the equal, the not equal, the very similar, the greater than, the less than. Remember, greater than is to the right, less than is to the left. Then you have another emblem or symbol, that goes like that. It means greater than or equal to. It's greater than or equal to. For example, if I was to have, oops, the square root of 81 is greater than or equal to 9. Would that be a true statement? Yes, the square root of 81 is 9. So if they said if true or false, is the square root of 81 equal or greater than or equal to 9, that is a correct statement. It is equal to 9. And they could have also said, going the other direction, this is less than or equal to. So let's look at this very carefully. The square root of 81 is also less than or equal to 9. That is also true. So if greater than and equal to and less than or equal to are basically the same, because they will be correct either way if it's a true statement. For example, here you have square root of 81 is less than or equal to 9. That is a true statement. So you have less than or equal to, greater than or equal to. So here we go. Equal sign, not equal, very similar, greater than, less than, greater than or equal to, less than or equal to. Then the last one here is percent. That is how a percentage sign is usually written. It is a percent, or sometimes you'll see PCT, percent. And percent means out of 100. So 60%, of 30. That's how you would see it. And remember, we have percent is part over the whole is equal to percent over 100. And remember, we did that in percentage. So this is something else. This is a formula that you should try to remember also. This is a formula, a proportional formula. The part over the whole is equal to percent over 100. We went over that extensively when we did percentage a few segments back. So we are through with this side of the basic symbols and signs. Equal, not equal to, very similar to, greater than, less than, greater than or equal to, less than or equal to, and percentage. Here we have bracket. The very top one is parenthesis. Parenthesis. Parenthesis parenthesis. It is the round brackets. That's what they usually say, but it's called parenthesis, and it depicts what you do first in an equation. So it brackets what it wants you to do first, because you have to do what's in the parenthesis first in the order of operation, and it also shows multiplication also. So when you have a parenthesis, I could say 6 times 4 equals 24. This means 6 multiplied by 4, or 4 multiplied by 6. However you look at it, it means multiply, parentheses right beside each other. And it also means do what's inside the parenthesis first. We did that with order of operations, because if you have an order, for example, 2 plus square root of 9 minus 2 to the second power. 2 plus the square root of 9 minus 2 to the second power. So you do what's in the parenthesis first. And when you're in the parenthesis, you do roots and exponent from left to right. So here you have roots and here you have exponents. We do roots first. So this would be 2 plus the square root of 9 is 3 minus, but I have to be careful because this is minus 2 to the second power. So that's minus 2 times minus 2. That should be a plus 4. Because when you're multiplying, or I'm sorry, when you're multiplying or dividing and the signs are negative, your answer will always be positive. When you're multiplying and or dividing and the signs are negative, your answer will always be positive. So this will be 2 plus 3 plus 4. You do what's in the parenthesis first again. So this is 2 plus 3 plus 4 is 7, which is equal to 9. That would be your answer. Parenthesis, the round brackets. Then the next one that's the actual brackets. That is what a bracket actually is. This right here. The first one is parenthesis, and this one is actually a bracket. So it's the same thing. If you have something in a bracket, you work what's inside the bracket first. And if you have a parenthesis inside a bracket or a bracket inside a bracket, you work from the inner one out. Alright, moving along, we have the plus sign. Plus means addition. And you'll see plus, you'll see addition, you'll see sum, you see total. They all mean add. The total amount is the sum of. It means add. Addition. This is the addition sign. Order of operation. Addition and subtraction from left to right. And this is subtraction, means take away, minus, from. All these are terms that they use for subtraction. Take away, from, minus, subtract. It means minus or subtraction. And this one here is an addition or subtraction, plus or minus. If I say 6 plus or minus 3, I would definitely have two answers, because 6 plus 3 is 9, or 6 minus 3 is 3. So 6 plus or minus 3 should be 9 or 3. Or it can very well be the margin of error. That's what it's called. The margin of error, plus or minus 3. So it can go either way. Here you have an asterisk. Asterisk. I hope I'm pronouncing it correct. Asterisk. And also it means multiply. You might see some computers just have the ability, or some people just use asterisk showing multiplication. 6, 3. That's 18. It means multiply. And sometimes you'll even see the numbers in parentheses with the asterisk between it. It means multiply. We have to remember them. So go back over the video. Look at ones that you don't remember or you didn't know and try to remember it. And just as important as signs and symbols are your timetables and your different formulas, like part over whole is equal percent over 100 for the percentage setup. But you must know the different formulas. And like I say, the timetables, if you know what 9 times 9, 81, 9 times 7 should be 63. You have to know your timetables. And when you know your timetables, look here, there are no rules when you're taking a test that say that you can't use a quick count on your finger. If you know what 6 times 5, 6 is 30, 6 is 36, 30, 31, 32, 33, 34, 35, 36, quick, and it's done. You get it correct. If that works for you, that's what you do, as long as you're getting it correct. But the quickest, because when you're doing a test, you're time bound. So the quickest way to go through a test is to know your timetable, so you do not have to count on your fingers or your toes, because that takes away time from what you're doing. So when you're trying to speed, the best thing is for you to know your timetables, for you to know what 1/4 is 0.25, 1/3 is 0.33, 2/3 is 0.66, 1/2 is 0.5, 1/4, I said that, 1.25, 3/4 is 0.75, and so on and so forth. Small things. Know your timetables, your 12 tables, your 10 tables, your 9 tables, your 8 tables, your 7 tables. Remember how to change a fraction to a decimal by dividing the top number by the bottom number, and how to change a decimal back to a fraction. Whatever place is behind the decimal point, that's how many zeros you put it over. You have to remember stuff that we've been over already in the past, in the various segments. And then now you apply it with your operations or your signs and symbols, and you, with knowledge of these things and knowledge of your timetable and your different formulas, that's a formula for success. You will be successful. You will get them right. So let's go through. We did parentheses, brackets, plus, minus, plus or minus, and now we are at asterisk, which means multiply. And also you will see this multiplication sign. In algebra they call it a cross, but it's the multiplication sign. It means multiply. And this asterisk means multiply, the multiplication sign or cross means multiply, and just parentheses by themselves mean multiply. Just like that, that means multiply. Or you may see the dot. I say it's a period, but it's really not a period, it's called a dot. But a period is a dot. Wow. But just call it a dot. Right in the center means multiply, 6 times 3, and multiply and product and times. When you're reading a problem in word form, for you to decipher what they're asking you, different terminology you must be aware of. The product of such and such is such and such. Product means multiply. Sum means addition. Total means add. Together means add. But product means multiply. Times mean multiply. Off means multiply. 20% off 60 means 20% times 60. We must remember these little terminologies. Subtraction means take away. From means take away. Difference means take away. You will remember these little terminologies because you will see them again. Please remember them. So the dot means multiply. The asterisk means multiply. The cross or the multiplication sign means multiply. Here I have the dot again, 6 times 6. 6 times 6 is 36. So we have parentheses, the round brackets, we have the actual brackets, we have plus sign, plus or sometimes you'll see this, minus or plus. Sometimes you see the minus on top. Means the same thing. But you do the operation first, that's at the top. So in this one, if I say 6 minus plus 3, I'm going to minus first. So 6 minus 3 is 3, or 6 plus 3 is 9. I do the top operation first. So it's 3 or 9. Historic multiplication. Over here I have division. This is a division sign or symbol. This means divide, universal. 6 divided by 3 equals 2. This means divide. Also, this is a slash. This symbol is a slash. It also means divide. It actually is 2/3, which would be 2/3, but it actually means 2 divided by 3. This is how you get a decimal. So it means divide. And this is a horizontal bar. It also means divide. This is an horizontal bar. It also means divide. So it's 1/2. This is an horizontal bar. This means 1 divided by 2, which is actually 0.5. So that is what the division is. Division into quotient or quotient. These are terminologies that they use. What is the quotient of 6 and 3? The quotient of 6 and 3 is 2, because quotient means divide. The difference of 6 and 3, the difference of 6 and 3 would be 3, because difference means to subtract. What is the product of 6 and 3? The product of 6 and 3 would be multiply. So 3 6s are 18. So product, multiply, quotient, divide, difference, subtract. We must remember total or sum means to add. We must remember the terms and associate it with the sign. So here you have divide. The slash also means divide. The horizontal bar also means divide. And this right here, I have a variable, a. A variable is just a letter, any letter. It can be A, B, C, D, X, Y, Z. They're all variables. This is just depicting a variable with an exponent, meaning to the second power or to the B power or whatever power it is to. So all this is saying, for example, 6 to the second power, an exponent, meaning this times itself this many times. So this would be 6 times 6, which is equal to 36. So 6 to the second power is 36. I want to go a little bit deeper with exponents. Just give me one moment. It's very important that we know all the exponents. Now, for example, I have here 6 to the second power, but also you may see 6 to the first power, or you may say 6 to the 0 power. 6 to the 0 power does not mean 6 degrees. That would be a different format. This means 6 to the 0 power, and um, any number to the 0 power is equal to 1. Any number to the 0 power is equal to 1. Any number to the first power is equal to that number itself, except 0, with the exception of the number 0. 0 to the first power is 0. But any number to the first power, whether it is 25, 25 to the first power is equal to 25. And 25 to the 0 power is equal to 1. Any number to the 0 power is equal to 1. Any number to the first power is equal to that number itself. So 25 to the first power is 25. 60 to the first power is 60. 1000 to the first power is 1. A to the first power is 1. 25 to the first power is 1. And then so on and so forth. 6 to the second power would be this number times itself that many times. So it's 6 times 6. And 6 to the third power is 6 times 6 times 6. And 6 to the fourth power, and so on and so forth. So it's 6 to the 0 power, 6 to the 1 power, 6 to the second power, 6 to the third power, 6 to the fourth power. 6 to the first power. 6 to the 0 power, 6 to the first power, 6 to the second power, 6 to the third power, 6 to the fourth power. 6 to the fourth power is just 6 times 6 times 6 times 6. 6 times itself 4 times. So we have exponents. Now here we have a segment of roots. Now when you have that symbol, it's universal, that it means square root. Sometimes you will see the number 2 right there, depicting square root. But if you do not see that little number right there, this is understood to be square root. Remember, some things we know because they are understood. A number, for example, the number 10. The number 10 is understood, or any number. The number 1, the number 0, the number 50, the number 10, the number 1 million. Any number is understood to be positive. So this is a positive 10. Even though you don't see the plus sign or the positive sign in front of it, it's understood to be positive. That's understood. It's understood to have a period or a dot or a decimal behind it. That's a decimal. Every number is understood to have a decimal, whether it's 10 or whether it's 6 or whether it's 7. It's understood to have a decimal behind it, and it's understood to be positive. Understood. All that's understood. And also, it's understood that they are over 1. And even the one that is over is understood to have a decimal, is understood to be positive. But we don't usually write it like that. It's just understood. So how do we write it? This is what we usually write. We write 10, 6, and 7. Those are numbers. But they are understood to have a decimal behind them, understood to be positive, so you have a plus sign in front of them, and understood to be over 1. So just like this now, this is understood to be square root. It means what number times itself gives you that. So for example, 196. This will be the square root of 196 is equal to 14, because 14 times itself is 196. But if it doesn't have a 2 there and have a 3, like that, that changes the whole dimension. That now means cube root. Cube root. So for example, if I have 27 right here, and let's say the cube root of 27, the cube root of 27 would be what number multiplied by itself 3 times, because it's cube means 3, that would give me this number. So it would be 3, because 3 times 3 times 3 is equal to 27. 3 3 is 9, 3 9 is 27. So the cube root of 27 is equal to 3. And so on and so forth. But this one must have the 3 there for it to be cube root. If it doesn't have a 3 there and doesn't have anything at all, then that would be square root. But to be cube root, it must have the 3 right there. Have to be there for it to be cube. And so on. Same thing goes for the fourth root or the quad root. You'll see a 4 right there. So for example, if I put 81 and I say the quad root of 81, that would be what number multiplied by itself 4 times. So that will be 3 times 3 times 3 times 3. 3 3 is 9, 3 9 is 27, 3 times 27 is 81. So the quad root of 81 is 3, or the fourth root of 81 would be 3. So these are what you should remember, these signs and symbols. So you have the division symbol or sign. You have also a slash. It's also a division sign. Also a horizontal bar is also a division sign. And then you have square root, cube root, and fourth root. And the square root is what number times itself give you that number. The cube root is what number times itself 3 times that give you that number. And it must have a little number 3 on the outside of it that depicts cube root. And the fourth root is what number times itself 4 times that give you this number. And it must have a little 4 on the outside depicting fourth root. The only one that does not or will not usually have a number is the square root, because it's understood that if it does not have a number, it is square root. This sign right here, this last symbol right here, means perpendicular. It means perpendicular. Perpendicular means at 90 degrees. So when you see a straight vertical line coming down straight to an horizontal line, that means this is perpendicular. Right there is always 90 degrees. But you will not always see this here. Oops. Basically, that's what you will see. Means perpendicular, 90 degrees. That means perpendicular. So you have cube root, I mean, fourth root, cube root, square root, horizontal line, that means divide, slash, that means divide, division sign, that means divide, and perpendicular means a 90-degree angle. So for example, this one right here, line AB is perpendicular to line CD. So this, for example, in this figure, just an example, just a hypothetical, in this figure, I have ABCD, where AB is a line, a horizontal line, and CD is a vertical line. But here it says line AB is perpendicular to line CD. So line AB is perpendicular to line CD. So that means this must be 90 degrees. And since we are talking about lines, here you have an horizontal bar with AB under it. It depicts a line, line AB. It could be line XY. It doesn't matter. Line XY. This is X and this is Y. So this will be line XY. You could have a line MN that's at a 40-degree angle. Line MN, and this is a 40-degree angle. It's so many different ways they could show you what a line is. Line XY. In a triangle, line XY is perpendicular to line AB. It's just a line. So line AB is perpendicular to line CD. This means perpendicular, meaning that it's at a 90-degree angle. That's what perpendicular means. And this right here, horizontal bar with two variables under it, it just means that line AB from A to B, line from X to Y, or line from A to B. Line AB is line from A to B, line CD is line from C to D. Line XY is line from X to Y. That's all it means. So we are finished with this rule. Okay, so here we are going off now a little more into geometry. And that's what our next segment will be about. Our next segment will be about geometry, where I will get into circles and triangles and squares and rectangles and cylinders, different forms and different shapes, how to find the volume, how to find the square, how to find the perimeter, how to find the circumference, how to find various things when it comes to different shapes and forms. That would be my next segment. So what I'm doing now is just brushing you up, sharpening your skills on the different signs and symbols that you will see as we progress. You saw some of them in algebra. You saw some of them in Pythagorean relationships. You must know the signs and the symbols so you will understand a question that's being asked when they put a sign of this magnitude or a symbol of this magnitude in the question. But it's not hard. That's why I'm going over them so you can remember them. Automatic. So here you will see this means angle. So for example, I would have angle ABC equals 40 degrees. Angle ABC equals 40 degrees. So for example, if I have a triangle ABC, and they say angle ABC equals 40, whatever one is in the middle, which is the B, that's the angle in question. That's the angle right there. ABC. So you start at A, go to B, and then go to C. The one in the middle, that's what they're talking about. That is 40 degrees. Angle ABC equals 40 degrees. Or they might say angle XYZ equals 90. Or angle XYZ is perpendicular. Angle XYZ is perpendicular. So I might have X, Y, Z. This is my triangle. And they say angle XYZ is perpendicular. If angle XYZ is perpendicular, this must be 90, because perpendicular means 90 degrees. So angle XYZ is perpendicular, and they're saying XYZ, that's the one in the middle. XYZ, the Y is in the middle. That's the angle in question. That's what they're talking about, the one in the middle. This is the angle XYZ. They could have said ZYX. It would still be this one. It will be the same one. And perpendicular means 90 degrees. Also, you will see this right here depicting angle. Angle AMX is 60 degrees. And let's talk about degrees for a minute. Because here I have a degree symbol. A degree symbol is this right here. I'll put it right here, 60 degrees. Degrees have various meanings. But for mathematical purposes, degree is the measurement of an angular unit. The degree is the measurement of an angular unit. That is what degree depicts. Now, degree is of an angular unit, and to get a full revolution of a complete angle, it's 360 degrees. So a total degree, the total angle, or the complete, which would be a circle, actually, is 360 degrees. So for example, let me show you what I'm saying. You have various angles, and for example, we'll start with the acute angle. Acute angle, acute angle is less than 90 degrees. That's an acute angle. Acute angle is less than 90 degrees. Then the next angle, these are important because they expect you to know these things also when you come to geometry or similar shapes or similar figures. You should know these things, the various angles. So this is less than 90. That's the acute. Then you have a right angle. And that's equal to 90 degrees. So right angle equals to 90 degrees. 90 degrees exactly. That's a right angle. So if somebody says a right triangle, they're talking about a 90 degrees triangle, like we talk about in Pythagorean relationship. Because for Pythagorean relationship to work, a square plus b square is equal to c square, where c is the hypotenuse and a and b are legs of a triangle. It must be a right triangle, a triangle that have a 90-degree angle, and the side across from the 90 degree is the hypotenuse. So the first angle that you should be aware of is an acute angle, which is less than 90 degrees, and then you have a right angle, which is 90 degrees, and then you have an obtuse angle, and this is more than more than 90, but less than 180. More than 90, an obtuse angle is more than 90 degrees, but less than 180. So you will more than likely find it to be an angle like this, because this would depict 90 degrees. So it passed the 90 degree. This will be the whole angle right here. So that angle would be more than 90 degrees, but less than 180. That's an obtuse angle. And contrary to popular to believe, I'm going to start taking these off the board up top. Contrary to popular belief, you have something that's called a straight angle, which is a straight line. A straight line, 180 degrees. A straight line is 180 degrees. This right here. Straight line. Then you will have a reflex angle. A reflex angle is more than 180, but less than 360. So you have a straight line and a reflex angle. A reflex angle is more than 180 degrees, because remember, 180 is a straight line. The straight line is like this. This is the angle in question. This is more than 180, but less than 360. And last but not least, you have the complete circle. The complete circle is 360 degrees. Complete revolution all the way around. That's this right here, a complete circle. We're going to talk about that in just a moment, because we are getting ready to go into geometry. We need to learn the terminologies and the different signs and symbols that are used in geometry. So here you would have an angle, and also this would depict a right angle. This would also depict a right angle. If you see this right here, it also means angle. But you could see, even although you do not see this little box here, it's still understood to be a right angle. And as I said earlier, this is line XY. Line XY. We just talked about that previously. The next one would be perpendicular. What does perpendicular mean? Perpendicular means it runs beside, they run beside each other for however long they run. The same space between them as far as they go. They don't get closer or they don't get wider apart. They don't get closer together, nor do they get wider apart. They stay right at the same distance between each other for as long as they're beside each other. That's what perpendicular means. So, for example, line XY is perpendicular to line MN. So this will be line XY and this will be line MN. They are perpendicular. They are the same distance here and also here. Perpendicular. Okay, so we have this is an angle, it depicts an angle. This also depicts an angle. This depicts a right angle. This depicts a line, line XY, which I have here. I also have line MN. It could be line N, it could be line OB. It doesn't matter. So that means this would be line OB. That's all it's telling you. O would be the beginning of the line and B would be at the end of the line. And here we have similar or equal to. It actually means congruent. And congruent means identical. So, if for example I have triangle ABC is congruent to triangle XYZ. What that tells me is that both triangles are identical in shape and in size. So you need to learn that. Because it has the equal sign with the similar, it is actually identical. Equal or similar to, but it's more equal than similar. It's identical actually. In algebra, this is used as congruent, and congruent means identical to. And this sign right here is a sign that is meaning that it is similar to. Similar in shape, but not in size. Different sizes. It's just similar in shape. You might have triangle ABC is similar to triangle XYZ, meaning you have two triangles. And they might be similar because this might be 45 degrees and this might be 45 degrees, this might be 90 degrees and this might be 90 degrees. So they are similar. The angles may be the same, but the size of the triangle are different. So they are just similar triangles, similar figures. We'll get to that when we get further on in geometry. So triangle ABC is similar to triangle XYZ. we have to remember how to use these symbols and what they're asking us. So we finish with angles here, come all the way down, and here you have triangle. That's what it means. Triangle ABC is congruent to triangle XYZ. That means triangle. Anytime you see this little symbol, it depicts triangle. And let's go further and let's try to wrap it up. Here we have a variable, x. X is just a variable. Y, Z, A, B, C. X is a variable. A variable is a letter. A letter is just a letter. A variable is just a letter. A letter is just a variable. It depicts the unknown. So we did that in algebra. So a variable is just a letter. So it's the unknown. So x equals 12, or 1/2 x equals square root of 144, for example. We could work that out. But what it depicts is the unknown. That's what a variable is. A variable is just a letter. And degrees, now I said degrees can mean many different things. Latitude, longitude, they're all written in degrees. When you're doing geography, stuff all written in degrees. When you're doing temperature, outside temperature, it's written in degrees. But for mathematical purposes, degree is the unit of measurement of an angle. This is always in degrees. For example, this might be 60 degrees. And the unit of measurement, I showed you the different angles. Acute angle, 90-degree angle, straight line, obtuse angle, reflex angle, and the circle, which is 360 degrees. Here we have greater than and less than, or much greater than and much less than. This means much greater than. So I might have 4 or 3.1 is much greater than 1.99. That's a fair statement. 3.1 is much greater than 1.99. That would be a fair statement. It's not equal to it, but it's greater than it, much greater than. I'll give it that. If I said true or false, 3.1 is much less than 1.99, would that be a true statement? No, that's incorrect. That would be false, because it's not less than 1.99. It is greater than 1.99, much greater than 1.99. So this is how they will use true or false. .1 is less than 1.99, or much less than. That is false. We know that. One-third is much greater than 0.247. I could have two things here. I could do it like that. That sign by itself would mean greater than. One-third is greater than 0.247. Is that a true statement? Yes, it is. Because remember, one-third is 0.33. So 0.33 is greater than 0.247. So this would be a true statement. One-third is greater than 0.247. But is it much greater than? Depends on what your measurement is depicted from. So it would also be a fair statement to say this is true, because it could be, you could say it's much greater than, at least 0.1 want something greater than. But we need to learn the terms. Here we have pi. Pi depicts the radius. Pi depicts the ratio between the circumference of a circle and the diameter of that same circle. So when I say circumference of the circle, we are talking actually about the perimeter of the circle. But when we are dealing with circles, we do not say perimeter, we say circumference. The circumference is the distance around the circle. Just like you say perimeter, the distance around a triangle, the distance around a square, the distance around a rectangle, that would be the perimeter, the distance around. But when you're dealing with circles, you do not say perimeter, you say circumference. So to deal with pi, pi is the ratio of circumference over the circumference to the diameter. And the circumference is the distance around the circle. And what is the diameter? Diameter is the distance across the circle. So it's the ratio of the distance around versus the distance across. And in every circle, in every single circle, it is understood that it is 3.14159, so on and so forth, or 22/7. That is what pi is understood to be. Pi is 3.14159, and it goes on. But I just stop at the 6th place or the 5th place. And or 22/7. If you divide 22 by 7, this is what you will get. So pi is just the ratio of the circumference of the circumference of a circle versus the diameter. And the diameter is the distance across, all the way across. From this point right here to this point right here, from X to Y would be the complete diameter of a circle. And the radius would be from the center, any straight line from the center of the circle to any point on the circumference of the circle. That would be the radius. The radius is also 1/2 the diameter. Half of the diameter. The diameter is the total distance across the circle, across the center of the circle, and the radius is always half of that. We'll get into that when we do geometry. That's the next segment. So pi is also 3.14159 or 22/7. And it's also understood to be the circumference, the ratio of the circumference to the diameter of whatever circle it is in question. And here we have a simple arc. That arc actually would mean angle AB. Same thing. It just depicts an angle. So for example, if I have a triangle, I could say this is AB. Or meaning angle AB equals 40 degrees. That's all it is saying. This angle right here. Angle AB equals 40 degrees. Okay, so, wow, we went over a lot of signs. Much greater than, much less than, degrees, remember degrees. Alright, we went over pi extensively. Pi is 3.14159 or 22 over 7. Basically, you will know which one to use, because when you're taking a test or a quiz or a segment, you always see where they express you to use 3.14, or they will say 22 over 7 as pi. When you're using a calculator, since you are using a calculator, a lot of times they will say use 3.14. But you will not have a problem. Once you know that pi is 3.14159, you don't even have to go that far. Just understand that it's 3.14. Stop right there. Pi is 3.14 or 22 over 7. And the diameter of a circle is a line that goes to the center, a straight line that goes straight to the center of the circle, straight to the other side of the circle. So it split the circles in half. Actually, it split the circle in half. It goes straight through and cut the circle in half. It's the direct distance across the center of the circle. The direct distance across the center of a circle, that's the diameter. And the radius is always half of the diameter. From the center of the circle, a straight line from the center going to any point on the circle. I hope this segment was very informative. I hope you understood what I was trying to present to you. I hope you understood the signs and the symbols, how they're used, their names. And please remember your timetables and the different formulas. Please remember 1/3 is 0.33, 1/4 is 0.25, 1/2 is 0.5, 3/4 is 0.75, 2/3 is 0.66. These things you should remember along with your timetables. Remember, when you're dealing with percentage, part over whole is equal percent over 100. Remember the different division bars, the slash, the horizontal line. Remember the different symbols that depicts triangle or congruent to, meaning that it's identical or equal to. Remember the different similarities, the different symbols, greater than or less than or perpendicular. Remember these. They are very important. And the more you learn them, the more you remember them, the more you will get your answers correct when you do a test. Thank you for watching this segment. I see you next time. The next segment is geometry. Thank you.